So here is another question on conditions for solvability of linear equations in two variables. So here we have to find the value of k for which the given system of equations below have infinitely many solutions. The equations are x plus k plus 1y is equal to 5 and k plus 1x plus 9y plus 1 minus 8k is equal to 0. Okay, so the first equation is not in standard form, so we have to write it in standard form. The second one is already in standard form. So x plus k plus 1y minus 5 is equal to 0 and k plus 1x plus 9y plus 1 minus 8k is equal to 0. Okay, now comparing it with the standard format, the values of the coefficients and constants are a1 is equal to 1, b1 is equal to k plus 1, c1 is equal to minus 5. a2 is equal to k plus 1, b2 is equal to 9 and c2 is 1 minus 8k. Okay, now the condition for infinitely many solutions, we have to find the value of k for that. So what is the condition now? The condition is, okay, it's not, okay, yes, okay, yes, the condition is a1 by a2 should be equal to b1 by b2 should be equal to c1 by c2. Okay, now here a1 by a2 is 1 by k plus 1, b1 by b2 is k plus 1 by 9, c1 by c2 is minus 5 by 1 minus 8k. Okay, so here let us compare. Okay, so 1 by k plus 1 with k plus 1 by 9. For the first comparison, let us make that 1 by k plus 1 with k plus 1 by 9. That implies k plus 1 whole square is equal to 9. Okay, that implies k plus 1 is root over of 9, which is equal to 3, but it can be minus 3 or plus 3. So when k plus 1 is minus 3, then k is equal to minus 3 minus 1, which is equal to minus 4. And when k plus 1 is plus 3, k is equal to, so I am writing or k is equal to 3 minus 1, which is equal to 2. So k is equal to minus 4 or k is equal to 2. Okay, so here I am writing k is equal to minus 4 or 2. So let us do the second comparison, because we have to do the second comparison to see what value we are getting. So let us compare 1 by k plus 1 with minus 5 by 1 minus 8k. So the second comparison, 1 by k plus 1 with minus 5 by 1 minus 8k. That implies 1 minus 8k is equal to minus 5 into k plus 1. That implies 1 minus 8k is equal to minus 5k minus 5. That implies 8k minus 5k is equal to, taking 8k to this side and minus 5 to the other side, so it is 5 plus 1. That implies 3k is equal to 6, or that implies k is equal to 2. So here we are getting k is equal to 2. Here we are getting k is equal to minus 4 or 2. So 2 satisfies both the comparisons. Okay, 2 satisfies both the comparisons. Here 2, here 2. So from these two comparisons, now there is no need for the third comparison. These two comparisons, we are getting 2 in both the cases, the value of k. So obviously 2 is the value for which the given system of linear equations in two variables will have infinitely many solutions. Okay, so this is the thing. K is equal to 2. So for k is equal to 2, these system of linear equations will have infinitely many solutions. Okay, so two comparisons are enough, because in exam you unnecessarily waste so much time. Okay, two comparisons are enough. For the sake of just showing, in the previous questions I showed you all the three comparisons, that any way you go you will get at the same result, but here two comparisons are enough. Okay, so k is equal to 2 in both the cases, so the solution is k is equal to 2. Okay, so this is the thing. So here is another question on solving the conditions for solvability for linear equations in two variables. So it is given, find the value of k for which the given system of equations has no solution. The equations are x plus 2y is equal to 5, and the other equation is 3x plus ky minus 15 is equal to 0. So first we'll write the equations. The second one is already in standard form, so the first one will be in standard form. It is x plus 2y minus 5 is equal to 0, and here it is 3x plus ky minus 15 is equal to 0. Okay, now here the values of the constants, they are a1 is equal to 1, b1 is equal to 2, c1 is equal to minus 5. So a2 is equal to 3, b2 is equal to k, c2 is equal to minus 15. Now before we proceed, first we should write the condition. What is the condition for the existence of no solution for a pair of linear equations in two variables? So it is a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. This is the condition. a1 by a2, which is the ratio of the coefficients of x, should be equal to the ratio of the coefficients of y, and both of them, it should not be equal to the ratio of the coefficients of the two constants. So here let us determine what these individual ratios are. So first, a1 by a2, that is equal to 1 by 3. b1 by b2, that is equal to 2 by k. We have to find the value of k. c1 by c2 is equal to minus 5 by minus 15, which is equal to 1 by 3. Now here there is something very interesting which is there. Here A1 by A2 is equal to C1 by C2. Okay, but for the condition, for the existence of no solution, this is the condition. For no solution, this is the condition, that is A1 by A2 should not be equal to C1 by C2, B1 by B2 should not be equal to C1 by C2. Okay, so here A1 by A2 is becoming equal to C1 by C2, which is equal to 1 by 3. So we are getting clear indication that there is no such value of K for which the above system of linear equations will have no solution. See how this happens. According to the original condition, A1 by A2 should be equal to B1 by B2. So 1 by 3 should be equal to 2 by K. So according to this, K should be equal to 6. Okay, this A1 by A2 should be equal to B1 by B2. But here B1 by B2 should not be equal to C1 by C2. It means 2 by K should not be equal to again 1 by 3, which is equal to C1 by C2. So 2 by K should be equal to 1 by 3, also it should not be equal to 1 by 3. So the existence of both of these conditions simultaneously, it is not possible, it is impossible for a ratio to be equal to a particular value and then not equal to that value. How is it possible? So this condition is not possible. So here it means 2 by K is not equal to 1 by 3, means K should not be equal to 6. So K should be equal to 6 and not equal to 6 at the same time. How is it possible? So here it is not possible. So there is no value of K for which the system of linear equations in two variables has no solution. Okay, for the given system of linear equations here. So this is a very good question, okay, where there was no value of K. Up until now, all the questions that we have solved, we have reached a particular value of K for which the system of equations satisfies the condition. But here there is no value of K for which the condition is satisfied. Okay, so this is a very good question, and this is that it is not possible to find a value of K for which the given system of equations has no solution. Okay.